All right. Well, good evening, good afternoon, everybody. Thanks, Leonardo, for the very nice introduction. So I'll talk to you about, we've been calling this, a proposal for federated AI for health. And again, I'll describe to you how this fits into the overall MPI framework and actually how it benefits from it. Of course, this is not work done in a vacuum. Actually here, sharing the title with my colleague, Ana de Almeida, here in Portugal, but also I have to thank and mention a number of our graduate students that also participate with us in this project. So first I start with the motivation of what led us to think about this topic, and then finally contribute this, our experience with it to MPI. So actually this got started in the COVID days, through a project that is ongoing and is actually financed by the Portuguese, fostering, research and innovation agency. The name of that project is AI Health, AIM Health. And what is it? It is actually a smartphone application, and actually, of course, is accompanied by a trustworthy AI, a distributed service-based platform. And the goal of that project was to identify, people who are symptomatic or not symptomatic yet. And at the time of the COVID days, when this started, was, COVID-19 patients. And also the goal was to alert the user for, any meaningful alteration of their health status. And so basically, in a sense, we intend to use our learnings in that project to inform, our MPI project, which I'll start describing, in a moment. So basically, in a sense, this started off as, a smartphone application that uses a secure, of course, we're dealing with health data, so it has to be security, privacy issues taken into account, and actually intend to address those as we go on. So this will be a distributed service platform. So how do we do that? And again, the idea was to use the smartphone in this case, but it's, again, our goal was to be a distributed, implementation. So people using, the application downloaded in their smartphones, we use that platform to collect data. And that data could also include the health data. Now, this has to be done in a secure way, has to be stored securely, so access to health data could be controlled and also could be shared by only in ways that are authorized by the user. And by the way, actually, I'll just give you a head start. We're actually looking at ways of implementing this because it's just not only a single user, but a multitude of users. We envision thousands of users on those applications. And this brings us to the next point. The point is that, distributed system would also be doing some local analysis of the data, and then combining that knowledge, the collective knowledge. I'll get to that later, but in a sense, I just describe how this is done. So we do the analysis using, machine learning model, and this, periodically gets, more and more knowledge, both about the individual user and also, some sort of aggregate knowledge, system-wide. And again, another key point, as I mentioned earlier, is to provide a secure backend, again, security because of privacy and also, other kinds of issues. And again, we wanted to adopt, and actually we elected to adopt what we call a federated edge computing architecture that is based on microservices. And actually, I just give you a heads up, this is all controlled, by smart contracts. I'll let you guys know about that in a minute. But the idea is that, personal and sensitive data, as long as any other, relevant data can be stored securely, and also the user has the ability to control and authorize the use for, situation in which it deems necessary, like access by his health provider. And actually, I'll get to that in a moment. I also want to point out that the smartphone itself, can be used as a data collection point, could be, by several ways of doing that, either by analyzing the user's voice. There's ways of using the smartphone, and we actually have a part of our project in which you're able to analyze someone's heartbeat. And by the way, we actually, in the course of this project, we learned that the resting heartbeat of someone, as you analyze that as a time series, is actually a quite powerful indicator of whether or not someone is about to come out with some infection, for example, by COVID. I may mention that a little bit later in my presentation, but let's move on to the next slide. So I wanted to basically mention that in a sense, we're looking at what you call federated, artificial intelligence for health data, which is our MPI-AIH project. And it supports the collection of health data, also the AI-based processing, and also support, very disciplined and controlled access to this. So these functionalities are supported by what you call our secure platform, and those characteristics are also defined, taking into account legal concerns such as the European GDPR. And again, we use what you call secure federated learning, and we also securely distributed updated AI models. I'll get to that in a moment, but as you can see right now, we're envisioning here something that is both local and also collective. So there's local processing, there's local security stored data, but also there's a component in which the multiple users collaborate and also share, in a sense, to create something that is global and more relevant. But before I get to that, I wanted to mention also that, again, this is a very familiar picture now to you all. Our goal is to, take advantage of this modularized, legal type AI. So, our implementation also allows and makes advantage of this, application workflows, which are, composed of several other modules, again, which we can, require and request from the MPI, the MPI store. And again, those modules, and actually part of our work is also define some of those modules, define their functionality, define the syntax of the data, define the APIs, and also defining the semantics of the data. And also as long as one of those modules, can be implemented and abides by the properly described interfaces on the implementation, could be implemented in software, in hardware, or using a kind of a hybrid implementation. So again, this is our view and how we intend to fit and also contribute to that system. So now, once we got that, I already told you about what we are, where we intend to do, one of the ways to do, and then what are the key components? Who are the key actors? So in our system, as you can see on the top left here, we have both the end user. This is the person using this application on their smartphones, but also we have other actors. So the user not only provides his or her own health-related data, and that data ends up being processed and stored into the AI health backend, which I'll talk about in a moment. And then the user can also control who has access to my data, and also audit who is looking at my data and so on. As I mentioned, this person may elect to give access to their personal doctor, to their physician. And later, at some point, the same user might be able to receive both, in their, version in their own smartphone, models or even data that is processed by the AI system, and that data can be even in the form of a health alert and so on. So that is one of the actors, the third party. And by third party here, we mention like hospital, clinics, research centers, the caretakers, other entities that might request and acquire access to the data, and also to be able to even request processing of the data on behalf of the user and extract such knowledge. And again, this is done through AI models. So, and by the way, let me, I cannot stress this, strongly enough. All of this is actually controlled and based, by using, smart contracts between the user and the third parties and so on. And just to finish on the left, the other platforms are other platforms beyond the AI system, which may collect subsidiary data or even might provide, overall data. It could be, overall, infection rates and things like that. And by the way, all of that communication is done, via smart contracts. So, and again, going ahead into describing the architecture of the systems, you can already, foresee we have our front-end system, which is, what lives and resides on the smartphone. We do have a back-end, which I'll talk about in a moment, which is, the bulk of the processing done. And again, this is helps to be done securely. So we both have the blockchain and distributed ledgers to do that, to also produce, to enable traceability. And of course, we have a number of AI system services that are done. And finally, this, compliance or PAI, Intelligent Computational Service Organization. Some key aspects of it, as I mentioned earlier, we have a federated learning approach, which has, a central point. And again, as clients, we have those mobile applications. And again, one of the key components of building these are the, multi-sourced, AI modules that we will be using for this. So this is a picture describing the architecture. So on the left, you see, the front end, which is a smart device that captures, store, processes, transfers, and receiving all the related data. And then the back end, as you can see in the center of the picture, implements services to securely store, de-identify, and also anonymize the data. And also the control, entity authentication, access to the data, and also, controls the licensing, auditing, even the access to that data. On the right, you see, an underlying technology, the blockchain, and distributed ledgers, and those enable transparency and auditability to the system. So as I mentioned earlier, each access to the data, requires a smart contract to do that. Finally, a number of AI services are downloaded from the Empire store and used to, treat the data that is, provided that's residing within the system. Let me talk a little bit more about the front-end system here. So basically, the user is using this, as you can see here, has the ability to do many things. First of all, he may be able to log in to sign into the AI system, which is equipped with secure features that initializes a secure data vault within his own device. And a user can also configure the AI health application to be able to connect to the other data sources, which are either external or even internal applications. Could be some biometric sensors within the proper, smartphone and things so on. So the users were some, demographic data, the age, weight, and so on. And then the application starts collecting relevant data from the user, and that data again is stored in a secure fashion within the data vault. And then, when necessary, the app may request from the user permission to export, specific, curated subsets of the data to the AI system, and then potentially to other third parties such as hospitals and so on that are authorized. If the permission is given, then the backend may create a smart contract, and the data we collected by the API for the identification. And once that data is provided to the system, I'll talk a little about now how this is done. And actually, this is our vision here. We do what you call federated learning. The idea is that multiple edge devices, and each one holds their data locally, but collectively they collaborate to train a global model. So actually, what you can see is this: we're not exchanging data from the user. We're actually exchanging deltas from a trained machine learning model. So as you can see in the picture here, each one of the clients has a version of the neural network that was trained. But as new data arrives, there's a incremental training that is done locally. So each one of the clients has a measure of incremental training, which creates a delta on the status of the network. We depict this as a delta weights. as you can see, what is transferred between each client and the server are just the deltas. So no data from the user is transferred, just those deltas. And again, the server is able to aggregate the contribution of several users, and then periodically that is created, incorporates, and results into a new model, and then that is also downloaded into the edge devices with the proper authorization and so on. I'll just briefly talk about what is required of such a system. This is our vision in how to make it work. First of all, the front end shall be persistent. They should run continuously. As I said, it has local storage. It also should enable, biometric sensor calibration. You want to make sure the data coming from multiple, devices is consistent. And of course, it has to agree, and the terms and conditions are all set in a smart contract, both between the front end and back end, and also the third parties to the back end. First of all, the number 4 here is that there's the ability for third parties, as I mentioned, hospitals and so on, to request certain kinds of AI processing on the data. Actually, I'll mention a bit later also the kinds of data types that the system will support. As you can imagine, these are medical style data. And of course, you can see here we list a number of interfaces within the system, both for allowing for auditing and licensing service, for all kinds of authentications, and again, accessing to control services and data storage, and again, interface between data storage and services, and also between the services that do de-identification and anonymization, and also between the backend itself and also the AI framework. So hopefully that I'm doing well on time. I just want to quickly mention kinds of data types, and here we describe it. We actually been discussing as we work on the standard, on maybe a proposed way of describing those, a suggested way, to have a very well defined semantics and syntax. But the kinds of data would be some kinds of electronic medical health records. Many of the data that we do process are time series data. As I mentioned earlier, the resting heart rate is a key indicator, and actually the early results that we have, that's quite a useful tool, and it's expressed to the systems as a time series of heartbeat measurements. We do also process sensor data from the devices themselves or attached to the device. Could also be things like smartwatches and fitness trackers, other kinds of data, geolocation, social media, text, and so on. So you get basically, we are trying to, predict and describe, to prepare the different kinds of data that such a system might be able to use. And finally, I'm getting close to my time here. So we are basically, at the end of stage 2, finishing up functional requirements and looking at commercial requirements. And we hope to get to the stage of a call for technologies relatively soon. And actually, we should also acknowledge Leonardo's contribution have been able to make it a number of substantial process right now. So again, we look forward for contributions and participation in the project, as well as thank the MPI community for allowing us to